All right, so this video might even be as short as Shelby wanted it to be. This is our video lesson on triangle similarity. So we've already talked about the differences between congruence and similarity quite a few times so far this chapter. So congruent, remember, means all sides are equal and all angles are going to be equal. In similarity, though, the sides are just going to be listed as proportional while all the angles are still equal. So if you remember, we had some theorems, some shortcuts for proving triangle congruence. And so those were side, 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 which means that all the sides, we've been given three congruent sides. Side, angle, side. Remember, that means the angle is in between. Angle, side, angle. And angle, angle, side. We've also determined that side, side angle has a shortcut, which is HL. That's hypotenuse leg, and it only works for right triangles. And then remember, lastly, with congruence, we said angle, angle, angle did not work. All right, now because similarity and congruence are very similar to each other, no pun intended, they share some of these same theorems. However, the ones for similarity work a little bit different. So for congruence, side, side, side meant three congruent sides. But for similarity, remember, it's not equal anymore, it's proportional. So for similarity, it's going to be three sets. So side, side, side is still a theorem, but we call it side, side, side similarity, where the sides are proportional, not congruent to one another. So that's what we would have to prove, is that they were proportional. Side, angle, side is also still a theorem, side, angle, side. And in that one, same idea. So the angle is going to be congruent, because we said angles have to be equal, but the sides are going to be proportional, like we said. Now, there is really like one other theorem left here. And the last theorem, well, I'll say HL still counts. It's kind of like the side, 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 because think with if you knew two sides of a right triangle, you could find the third. So with HL, it's still that same like side, side, side idea or concept, except for that with similarity, we need these to be proportional as well. And now the others, I haven't actually talked about the one that you all know to be true the most about similarity. The very first theorem that we said to be true about similarity was this angle, 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 because we knew that that was going to be, even if the sides are different lengths, all three angles are going to be congruent, which is the definition of similar figures. So side, side angle still doesn't work. But the angle, angle, angle does. And the reason I haven't written that down is because really, all of these things, angle, side, angle, 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 side, and angle, 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 all become one theorem, and that is the biggest similarity theorem, and it is called angle, angle. And that's not because the figure that you have is only going to have two angles, but think about in a triangle, the angles always add to 180. So if I know two of them, I'm always going to know the third angle. All right, so let me give you an example of that, but go ahead and do write down that angle-angle similarity is going to be your last and biggest similarity theorem. Okay, so here's two quick examples. The first one is what I was just telling you about. We have two sets of angles that are congruent. And even if I don't know the third one, I can go ahead and say that these are going to be similar triangles. But the reason I can say that is if you think about this first one, if I wanted to find this third angle down here, I could add these other two together, right, and get 150, and then subtract that from 180 since they have to add to equal 180. So when I do that, I'm going to get that this last angle is 30 degrees. Well, it turns out I'm doing the exact same math problem in the other triangle, no matter its physical size as far as side length, so I'm going to get 30 degrees again. So even without having to find that third angle, I can say that these two triangles are similar by angle-angle similarity. Now question 2 is a little bit trickier. They don't really have anything marked other than I have two sets of parallel sides. Now, take a second to notice in question number 2, there are two triangles, right? There's a smaller one, and then there's a larger one. There's one angle that they already share in common, and that's this top angle. So this angle up here is congruent to itself, if you remember, because of the reflexive property. And then if we want to use the parallel sides, we talked about before that we could draw our two parallels, and we pick our transversal based on a line that's shared by both triangles. So that could be either one of these sides. So I'm just going to pick this side on the left. If I do the Z, what we've talked about, then I get this angle that's outside of the triangle, and that's not really helpful. So instead, I can mark corresponding angles here. And in this picture, it actually doesn't matter where you mark corresponding angles, because in either spot, you end up having two sets of congruent angles in the triangle. I hope that you see that in the small triangle, you've got this angle at the top, and then this angle to the left. And then in the large triangle, you got the angle at the top and this angle on the left. All right, but this is an example, again, of angle-angle similarity, which means those two triangles are going to be similar. So make sure you've got notes for tomorrow, and we'll keep practicing this together.